tonight on Daily Planet.
Mark Miller visits the Vancouver Airport's new massive three-sided structure built to muffle the roar of jet engines.
And this week, Mark's hanging out at one end of the Vancouver Airport.
That's right. He's there to find out how to keep jet engine noise under wraps.
Airports are busy, noisy places, and Vancouver International is no exception. Rain or shine, each day, hundreds of aircraft and thousands of passengers make YVR the second busiest airport in Canada, and one of the loudest local landmarks.
We are really located within the city of Richmond, right beside the city of Vancouver, and so people live quite close to the airport, and we want to do everything we can to reduce that noise.
Kind of see the thickness of the walls and the structure.
Turns out it takes a monumental building to minimize an airport's acoustic footprint.
Wow.
So YVR built this.
Yeah, you don't really realize how big it is until you get out here.
Think of it as a 3-story tall silencer for aircraft engine testing.
So we have 3 big walls here.
15 meters
15
high.
meters high here, okay.
And 10 meters high on this side.
Called a ground run-up enclosure, it was built for airlines to conduct engine run-ups. Noisy routine maintenance normally done out in the open and at night. The 3-sided structure is designed to absorb and redirect the sound, reducing noise levels.
It's very unique. It's the first of its kind in Canada, and it shows our commitment to the community in reducing aircraft noise.
So we'll stress it as much as we can.
Tonight, I've been asked to put the enclosure to the test from the cockpit of a twin-engine turboprop.
Many of the 2000.
But first, engineer Mark Chang gives me a look inside.
Basically, the nose of the aircraft would be facing out towards the entrance.
And the
Engine's kind of facing the back, and then this is designed to take the jet blast and the prop blast from the engine.
Like a big ski jump.
The blast deflector redirects thrust up and out, which makes run-ups less turbulent and more safe for the aircraft.
So this isn't really sound absorbent. This is just redirecting jet blast.
Redirecting the exhaust, so the gas doesn't recirculate back into the facility and potentially damage the engine.
To dampen the noise, nearly 2,000 acoustic panels line the walls.
And the sound absorbing quality of this thing is in these panels in here.
That's correct.
Each panel is filled with 6 inches of sound deadening fiberglass.
So put your ear to it and kind of hear how dampening it is.
Yeah, there's nothing there.
Of course, what matters most is just how much sound escapes to the outside. Now the pilot in me is itching to give it a real test.
Are you worried that may damage your beautiful new
No,
toy?
I'm pretty sure. I'm pretty confident that we'll be able to handle whatever you have in store for us.
Okay, good.
It's another busy night at the Pacific Coastal Airways hangar. Maintenance teams are readying the fleet for morning flights, and engine run-ups are part of the routine.
You'll run it up. I mean, will you just start it up and just let it idle, or do you like run it up?
Nope, we'll take it up to the maximum capacity that it can do.
Because you don't want to find out that it isn't doing what it's supposed to do when you're up at 22,000 feet.
Exactly.
I've been invited to help taxi a Saab 340 over to the new test facility.
We're going to spark up these 2 engines. We're going to go over there, and we're basically going to stress the airplane. We're going to make the airplane think it's flying.
Aircraft maintenance engineer Aaron Reiki
Everything's over here on the tiller.
sparks up the engines.
The right prop arc looks like it's clear. Prop arc is clear.
And after a short taxi across to the enclosure,
Yeah, you can taxi in at your discretion.
we enter the acoustic bay and turn 180 degrees to point our thrust directly back at that blast deflector.
Okay, looks like we're just about ready to perform the run-up.
Now we throttle up. 2 1,800 horsepower engines come to life. We power them all the way to takeoff speed. Even at full power and only meters from the back wall, the airflow is designed to escape, so the aircraft isn't damaged by any turbulence. But the noise being produced can only be measured outside the aircraft.
So let's shut that one down. let me jump out. I'm going to take the device that's going to measure the amount of sound that's being produced. And I'm going to go on the other side of the wall, see if I can hear you. Okay.
Let's cross our fingers.
Okay.
So once again, I join Mark Chang, this time armed with a decibel meter.
So just in idle, we're getting about 77 decibels. Stand by, it's going to get kind of loud here in a second.
Another full power run up, and the decibels quickly rise.
Right now, 82 decibels. 92 decibels, like a rock concert.
On the backside, the gauge shows nearly half the sound has either vanished or been absorbed.
The numbers have dropped way down. 60 decibels back here. That's amazing. That makes a huge difference.
Within minutes, the test is over, and as soon as the SAB 340 rolls out, another aircraft rolls in for a late-night run-up. But thanks to acoustic engineering and a special new building, chances are the airport's neighbors will sleep right through it.